So here we are with number 10. In number 10, you have to go back to basics. They're asking you to find the exact value, and they're giving you something to the effect of, sine theta is equal to negative 4 over 9, and then they're telling you that tan theta is positive. So go back to a couple of things. First of all trig functions are positive here. Sine is positive here. Trig is positive here. Tan is positive here. This should be a tan function. And cosine is positive here. So according to this, if tan is positive, which is your first focal point, you should be asking yourself, well, if this is a positive, first of all, then it's either this quadrant or this quadrant, and it cannot be either of these two. Second thing to note, you see this negative? If you go back to your ratios, remember you have sine, which is y over r, you have cosine, x over r, and you have tan, which is y over x. If that is the truth, then y has to be negative and r positive, or r really doesn't impact us. So in that case, I know that x has to be over here somewhere, and x is 65 for whatever, it's worth. And this is the only way that y would be negative. So y would be negative 4, your r is 9, and your x has to be square root of 65, which is approximately 8. Okay? And so in that case, then, if you're now using the root, the actual function itself, and this is theta, and I know that theta is negative 4 over 9, that's sine of theta, then in this case, the secant of this, okay, and again, go back to your secant, would be r over x, because that's the opposite of cosine, the secant. So I'm looking at r over x. Remember, this is r. That's x. So I end up with 9 over square root of 65, but I need to multiply by square root of 65 top and bottom. So this will now become 9 square root of 65 top and bottom. 9 square root of 65 over 65 negative. So negative 9 square root 65 over 65. And it will be a negative value. It has to be negative. Okay, so that is number 10. Number 11. On number 11, you have cotan of theta is equal to negative 3 over 2. They're also telling you the cosine theta is negative. Okay. All positive. Sine is positive. Tan is positive. Cosine is positive. So if cosine theta is a negative, it's not this quadrant and it's not this quadrant. It's one of these two. In cotan, remember tan is y over r. So this is, y over x. So this is x over y. So that means that x is negative. X would have to be the negative 3. Y would be positive. So this one is going in this direction. I'm looking at cosine theta being negative. I now want to find cosecant. Keep in mind that sine is y over r. Cosecant is r over y. I can either solve for r. Remember, r is going to be the square root of negative 3 squared plus 4 squared. And therefore, square root of 13 would be our value for r. Okay, so here we are, square root of 13. Alright, if I'm finding cosecant of theta, I'm looking again at R, which is square root of 13, over y, which is 2. And so that would be number 11. Answer choice would be D. Alright, number 12. On number 12, you have cosine theta is equal to 8 over 17. Again, remember your ratio. This is x over r. They're telling us that 3 pi over 2 is less than 0, less than 2 pi. Okay, they're also telling us to find the cotan of theta. So in this case, we just really need to find r. If we have cosine, we have x over r, we need to find y, because we're missing y. And this would be x over y. So in this case, I should end up with negative 8 over 15. And this is one of those trigonometric identities. Let's see here. 8 squared plus 15 squared is one of those identities. Yeah, that equals to 89. So it's the 8, 15, 17 trigonometric, or I should say Pythagorean triplet. And so that has to be the missing value. Now, because we're finding cotan, remember cotan is x over y, and again, this would have to be negative. This is telling us that right there. That's telling us that theta is in that quadrant anyway. When we go back to our ratios, all students take trig or take calculus or a smart trig class, however you want to memorize it. That tells you which ones are positive. Alright, number 13. Okay, so number 13 is reference angles. We have negative 250 degrees. And if you remember the reference angle, you start from here, going distal. 90, 180. 180 plus 70, which means that this is 20 degrees here. This is 70 degrees here. But the reference angle brings you back to this 180 reference. So in this case, our reference angle has to be B. It has to be 70 degrees. Okay? That's the reference angle. Always back to the x-axis. Alright, number 14. Number 14, they give you 5.2. This is the one that I told you to simply multiply and convert back using the radian formula. And so when you're done with this one, you should get approximately 1.08 when you convert it back. Let's double check that for 1 second. Let me see. And I believe your mode has to be in radian mode as well. So yeah, that one's pretty straightforward. Alright, number 15. Let's look at 15 real quick. More reference angle questions. 15 to 18 I'm not going to labor on, because 15 to 18, it's the, repetitious. I'll do one more of this. This one is asking you for cosecant negative 2 pi over 3. And so, again, using reference angles. One of the little tricks that I use is that I multiply this by 180 over pi, and I kind of cheat the system in a sense. The pi's cancel, 3 goes into this 60 times, and you can see you end up with negative 120 for an angle, for a degree. And so, if we're looking for a reference angle, and I'm going back 90 plus another 30, so I'm about here, there's 30 degrees. I'm going to shoot back to this particular part of the x-axis, which means that this is a 60-degree angle. So in this case, if you're looking at it as a 30, 60, 90, and this is your 90, here's your 30 now, right? If this is 30, 60, 90, this is 1, this is square root of 3, and the hypotenuse is going to be 2. And if you have trouble remembering this, like some of us do, especially as we get older, this actually is the hypotenuse, is how I remember it. So that's the square, that's the 2, excuse me, this is plain old 2. No, oh my goodness. Let's just erase that real quick. So this is your 2, plain old 2. Alright, and so in this case, if I'm trying to locate the value, I'm going to do negative, I'm going to end up with negative 2 over square root of 3, but I'm going to rationalize this. So I'm going to multiply square root of 3 over square root of 3 to get negative 2 square root of 3 over 3. You can remember, again, the ratio where cosecant, again, lines up with sine. And if sine is y over r, this is r over y. Okay, so here's r in the green. That's r. And here's your y. Okay, and just remember, we don't like radicals in the denominator. Alright, I'll do number 16, I guess. Okay, so 16, you have the cotan of negative 5 pi over 6. And so same thing for this one, just remember tan is y over x, and therefore cotan is simply x over y. So if cotan is x over y, then I can solve for this. Also keep in mind that that's a negative, so that's going to also help figure this out. Now if I take negative 5 pi over 6 and I convert it to degrees, again, it helps you see the big picture. So I know that the pi's cancel. 6 goes into 180 30 times. 30 times negative 5, negative 150 degrees. So I'm drawing my angle from 90 plus another 60, so 90 and 60 degrees gives you the 150. My reference angle is 30 degrees and it's sitting right in there. So if I draw my triangle, this is a 30, 60, 90, right? And same applies in this case. So okay, 30, 60, 90, we go back to the ratio. I have to make it a little bigger so I can read it better. So here is R. R is going to be here in this little area. This is your Y. This is Y. Oh my goodness. This is on the plane. Alright, and obviously X is what's left over. That's X. Okay, so we're looking for cotan. So we said cotan is going to be, again, remember your ratios. If this is the 1, this is 30, goes opposite 1. R is 2. R is 2. And this is square root of 3. So we use our ratios again. What is the ratio for the cotan? This should end up being a square root of 3 because it should be square root of 3 over 1. Okay, because if tan is y over x, then cotan has to be x over y. So that's why we get square root of 3 over 2, or over 1, finally. Alright, now the next question. The next question is really not that complicated. You're looking at number 17. They're asking you for the sine, reference angle for the sine of 855 degrees. Okay. It goes around at least twice. We know that because 720, right? Two times around. So let's just not beat a dead horse, and 2 times 360 gives us this, and then we end up with 135. And now we're positive. Positive 135. If that's the case, what's left over, if I take 180 and I say, okay, I've got 180 minus 135, I'm left with 45. Obviously these are degrees. And, okay, in this case, you should end up with a 45 degree triangle. It is also a sine angle. So we know that sine in this case is going to be, I don't know what's wrong with my pen today. Sine is simply going to be y over r, and we should end up with 1 over square root of 2 for the angle. So if we draw it out, this is 1 square root of 2. If this is the 90 degree, this is 45. And you should be able to rationalize it. So if you have 1 over square root of 2, you simply multiply square root of 2 top and bottom, that cancels. You need square root of 2 over 2, which is answer choice D. Okay? I'm going to stop that video there. You can do number 18. It's the same concept.